I think developers instinctually recognize the value of automating repetitive tasks, and there's nothing as repetitive as testing software. As developers, writing tests is part of our daily activities. Once written, automating the test should be easy if we follow a few principles, and if we put at the center of this process a continuous integration system. So what are the marks of good tests that can be automated? First, tests are fast. They provide fast feedback loops. When you have a slow feedback loop, it's one of the most insidious things you can have in a software project. Good tests also improve quality. Tests drive quality and act as a gate to prevent bad commits from reaching production. A good test reduces the risk of introducing failures and finds regressions. They should be robust enough to not introduce false positive or flakiness. As Kent Beck said, make change easy, then make easy the change. Good tests are easy to write. Tests are code too and can have errors. Because it's impractical to test tests themselves, they should be easy to write to reduce the chance of introducing false positives. Good tests also help us understand the code. We should always be able to use a test as a reference for code behavior. Good tests are easy to run. Automated tests should start without any human intervention. A CI/CD platform like Semaphore can run your test on every change. You can also configure your test to run automatically using Git hooks or by configuring your IDE. We usually work with tight deadlines, and when we are crunching, it's very tempting to try to save some time by focusing less on tests. This is usually a mistake. Let's see a few myths around test automation. Testing can slow down development, and that's true because writing tests takes time from writing functional code. If you are really in a tight spot, it can be worth your while to take some technical depth and don't write the test in exchange for a faster delivery. However, in the long run, tests are an investment. You write them once and run them forever. When you have tests, you can move faster because you have a perimeter alarm that detects when an error has dropped in. Testing's only purpose is to find bugs. This is another misconception. Testing is not only about finding bugs like this one, the first computer bug ever detected, but it's also about improving the quality of the software. When coupled with something like TDD or BDD, it also participates in the design process. Another common myth is that testing only works if you have 100% coverage. Trying to reach 100% coverage is both dangerous and inefficient. First, there is such thing as code too trivial to test, so that's the inefficient part. Second, it gives us the false sense of confidence. The coverage figure only tells us how much of the code is covered by at least one test, but it doesn't say if that test is effective. Finally, we can say that testing is wasteful or inefficient, and it can be if it's done incorrectly, but it doesn't have to be inefficient. We can think of this time spent in writing tests as an investment. Developers can move fast thanks to the confidence that the safety net of the test brings. So instead of being inefficient, it's something that enables developers to work faster. Now, at the heart of this automation, we have continuous integration. The idea behind continuous integration is simple. Let's run the tests every time something changes. So you refactor a function, you run a test. Mike adds a feature, you run a test. Debra fixes a bug, again, you run a test. That's the continuous part. We can and should run the test before our commit into the repository. But when we have a pull request, when we have a commit directly into the branch, the CI should also pick that change and run the test for us. Running the test in our machine is a great start, but I don't think that's good enough. We should also have some system that takes responsibility for running the test for us and keeping a history of when things break and how they broke. This is exactly the problem a continuous integration platform solves. It runs our test in a reproducible environment every time there is a change in our code. So why should we automate our test with continuous integration? The first is the integration part. Continuous integration is a tool that encourages us to frequently merge and push our changes into the repository, because that's the way the CI system picks the changes and tests them. And that test can run in the background while we are doing other things. With each integration, the CI system can build our application from scratch, and that tells us if the application is still buildable, which is a very valuable piece of information. We get quick feedback on the state of our code. If a test fails, we can know immediately that something is wrong, and we can take corrective actions immediately. We also get consistent results because the CI systems provide a standard and reproducible environment when we run the test, and we eliminate the "it works on my machine" problem. Many tools provide also parallel testing, which allows you to run a test suite in various parts or various jobs, and this reduces the time it takes to get the results. This is especially important when you have a large test suite that may take minutes to run in your machine, and it should in theory take seconds in a good CI system. And finally, we get a history of the project. We see how much time it took from conceiving a feature to implementing and releasing them, how much failures we had on deployment, how much bugs we detected, how many regressions. This data will allow us to make better estimations in the future, and now and maybe take corrective actions if there's something wrong in our software delivery cycle. We get the most of test automation when we couple that with continuous integration. This is both a practice and a set of tools that enable that practices. Writing tests should be as common as writing code, and if you can invest time to write good tests, the returns will be paid many times over during the course of the project. Thank you for watching to the end. If you like this video, please like, subscribe, comment, tell us your opinion. We love to hear from you. Thank you for watching, and take care, you all.